Welcome to the deep dive. We are here to take foundational architecture documents and turn them into clear, actionable knowledge.
And today, we're getting into something I think is critical for anyone building distributed systems.
Absolutely. If you are preparing for a big system redesign or maybe just trying to figure out why your services keep breaking when they talk to each other, this deep dive is for you.
We're looking at from data to contract, architecting reliable systems with JSON schema. And our mission really is to show how you can move past these implicit assumptions about data.
And instead, use a machine readable blueprint.
Exactly, a blueprint for ultimate reliability and honestly speed.
Okay, so let's set the stage. We have to start with JSON itself. It's the universal language of the web, defined by RFC 8259.
Right, everyone loves it. It's simple, it's text-based, language agnostic, it's everywhere.
But that's the paradox, isn't it? Its greatest strength, that simplicity, is also its biggest weakness.
It is. Because JSON at its core is just a collection of key value pairs. It has no formal grammar built in. It's just too open to interpretation.
And that interpretation, spread across dozens of microservices, that's where the cost comes in. We see three specific pain points that just lead to brittle systems.
The first one is ambiguity. It's the most common one.
Right, you get a JSON payload and you have to guess. Is the user to field a string or a number?
Is it even required for this particular operation? Every team consuming that data has to make an assumption, and they bake that assumption right into their code.
So fragile. The second cost, then, is incompleteness.
Yeah, JSON doesn't tell you what's missing. An API might get a request that looks perfectly fine on the surface.
But if the client forgot to include, say, a user's country code.
Exactly. The system doesn't throw a formal error right away.
Yeah.
That failure gets pushed downstream, and you only find out when, some critical business process breaks hours later.
And the last one is that it's just undocumented, inherently.
Completely. There are no native features for descriptions or comments in JSON. So you end up with a separate Swagger file or a Confluence page that somebody has to manually keep updated.
And we all know how that goes. It falls out of sync on day two.
It always does. So you have this universal language that forces every single team to write their own validation from scratch. It's a maintenance nightmare.
Which is where JSON schema comes in.
It is. It's a declarative language that sits on top of JSON. It lets you define a standardized, explicit contract, a blueprint for what your data must look like.
So what does that blueprint buy us right away? What's the immediate impact?
I'd say three core benefits pop up immediately. First, you enforce integrity with machine-readable validation.
Okay.
Second, you can generate documentation that is, by definition, always in sync. And third, you ensure interoperability because everyone is forced to speak the same structured language.
Let's dig into that first one, integrity. That feels foundational. This is where JSON schema uses validation keywords to give you really granular control.
This is your first line of defense. Take a simple product object. We need certainty about its fields, so we use the type keyword.
To say, for instance, that a product ID must be an integer.
Yes. No more guessing if it's a string that just happens to contain numbers, it must be an integer. That ambiguity is gone.
And you can go deeper than just types, right? To enforce actual business rules.
Of course. Take the price field. You can use a value constraint, like minimum, to ensure that a product's price is, say, greater than or equal to 0.
So no one can accidentally check in a product with a negative price.
Exactly. And that rule is defined once in the schema, not buried in 5 different code bases in 5 different languages.
Which brings us to required fields. You can just explicitly state what has to be there.
Right. You use the required array to list them out. Producted, product name, and price must be present. If they're missing, validation fails immediately. That incompleteness problem is solved.
What about arrays, like a list of product tags?
That's covered too. You can use min items to say a product has to have at least one tag, and you can use unique items to make sure nobody adds the sale tag twice.
The immediate feedback is the game changer here. I mean, I've spent days tracking down a bug just because one service sent an integer where another expected a string.
We all have.
With this schema, if someone sends a product with a price of negative $15, that minimum constraint catches it instantly. That bad data never even touches your business logic.
You're not just validating, you are strategically protecting your most critical systems, your database, your payment processor, at the earliest possible point.
Okay, so validation is table stakes. But this is where it gets interesting, where the schema starts to act more like a system architect.
Right, we're moving beyond simple types to model complex conditional business rules. This is about cutting down on application code.
From static checks to dynamic logic.
Exactly. The schema can define how properties relate to each other. A keyword here is dependent required.
Give us the classic use case, the e-commerce checkout.
Perfect. The rule is, if you provide a credit card object, then you absolutely must also provide a billing address.
You don't want to rely on every backend developer to remember to code that check.
You declare it once in the schema, dependent required. The schema enforces that conditional link for you automatically.
But the real power, I think, comes with conditional logic, with if, then, and else. This is where the schema becomes a dynamic logic gate.
This is where you can replace dozens of lines of boilerplate code in your application. The canonical example is international addresses.
Right. The format for a postal code depends entirely on the country.
Wait, okay, but why wouldn't I just write a little validation function for that in my app? It seems simple.
You could, but the moment you have a React front end, a Java mobile API, and a Python data pipeline, they all have to duplicate that same logic.
Good
By
point.
putting it in the schema, you centralize the rule. The schema says, if the country is United States of America, then the postal code must match the 5-digit pattern. Else it must match, say, the Canadian alphanumeric pattern. The logic is now portable. And validation can tell you exactly which rule was violated.
That's the difference between simple validation and true data governance.
And as you build out these contracts, you hit the next challenge, which is scale. How do you avoid duplicating these definitions all over the place?
The microservice nightmare. The address object is defined in 6 different services, and they're all just slightly different.
That's where JSON Schema gives you an architectural toolkit with defs and refs.
This is how we enforce the DRY principle. Don't repeat yourself for our data structures. You define a common component, like that address structure, one time,
You put it in a central common.json file under the defs section.
and that becomes a reusable artifact. Any other schema, like customer.json, just references it with ref.
So your customer.json might have a shipping address and a billing address.
And both of them just point to that single canonical address definition.
The architectural win there is huge. If the company decides all zip codes must now be mandatory, you update it in one place.
One file. And every single consuming service is instantly validated against that new rule. It just eliminates those subtle, painful integration bugs.
Okay, we've covered reliability, structure, crucial stuff. But the real value multiplier is when we shift from defensive validation to development acceleration.
This is where the schema stops being just a guardrail and becomes a generative tool for your entire pipeline. The ecosystem is incredibly mature here.
Let's talk about the first big accelerator, type generation. I think this is the one people feel immediately.
For sure. Tools like JSON schema to TypeScript will read your schema and automatically generate the corresponding code types. Think TypeScript interfaces or C# classes.
Wait, so I don't have to manually keep my TypeScript types in sync with my schema definition anymore?
You don't. You run the generator. The manual translation step is gone. Your code types are guaranteed to align with the API's data contract.
So if the API contract changes, my types change, and the compiler just tells me everywhere my code is broken.
Instantly. It makes refactoring so much safer and faster.
Okay, that's huge. What's accelerator number 2?
Automatic UI generation. This one is amazing for front-end developers.
For building forms?
Yeah, for data entry. Libraries like React JSON schema form can take your schema and just generate the whole form. Inputs, labels, validation feedback, all of it.
So if the schema says a field is a required string with a minimum length of 5,
The UI just renders a text input with that constraint already built in. Building basic CRU'd forms becomes almost trivial.
wow. Okay, accelerator 3.
In-ID intelligence. This helps even non-engineers who are working with, say, complex YAML or JSON configuration files.
Oh, I use this every day.
Your IDE, like VS Code, loads the schema and gives you real-time feedback while you type. You get auto-completion, tooltips with descriptions.
And bright red squiggly lines the second you do something wrong. It's a lifesaver.
It guides you. And finally, number 4, which is critical for CI/CD, fake data generation.
For contract testing.
Exactly. Tools like JSON Schema Faker use your schema to generate valid sample data for your tests.
But why is that better than just having static test files?
Because your static files become obsolete the second your schema changes. If you add a new required field, all your old test data is now invalid.
But if you generate it from the schema,
Your test data pipeline automatically adapts. Your test suites are always accurate, always comprehensive. You can actually trust your automation.
that's a powerful ecosystem. But, for this to work, the core tooling has to be solid. Let's talk about the ecosystem itself.
Right. We have to mention OJV, which stands for Another JSON Schema Validator.
It's basically the standard in the JavaScript world.
It is. And it's incredibly fast. Its secret sauce is that it doesn't just interpret the schema at runtime. It precompiles your schema down into highly optimized standalone JavaScript validation code.
So the runtime validation is almost instantaneous. That's critical for a high throughput API.
Absolutely. And it's important to note the standard itself is still evolving. The latest big version, Draft 2020-12, made a really important change. It wasn't backwards compatible, but it cleared up a lot of ambiguity around arrays.
What was the ambiguity?
Well, the old items keyword was overloaded. It was trying to do two different jobs.
Okay.
It was used for fixed structure arrays, like tuples, and also for homogeneous lists where every item is the same. It got messy.
So how did Draft 2020-12 fix that?
It introduced dedicated keywords. For positional validation for tuples, they added prefix items.
Can you give us a concrete example of that?
Sure, think of a 3D coordinate. It's always an array of X, Y, Z. With prefix items, you can say the first item must be a number, the second must be a number, and the third must be a number.
So if someone sends 150 string, it fails.
It fails, and it tells you why. The third item's type is wrong. The structure is fixed and predictable.
So that leaves the simple items keyword to do just one job now.
Just one. It's now strictly for homogeneous lists, like a list of color hex codes where every single item in the array must be a string matching a certain pattern. It's so much cleaner.
This level of detail, it really requires an organizational commitment. So let's close out with some strategic recommendations. If you want this to work at scale, what do you have to do?
Recommendation 1 is non-negotiable. Establish a centralized schema repository. Your schemas are architectural artifacts. They need to live in their own version-controlled repo, separate from your application code.
Why is that separation so important?
Because it enables maximum reuse with ref. It ensures data governance is centralized. The customer service owns the customer schema. The inventory service just references it. No shadow IT, no drift.
Okay, recommendation 2 is more operational.
Implement validation at the gateway. You have to validate at the earliest possible entry point, your API gateway, your network ingress.
Hold on, doesn't running that much validation on every single request add a ton of latency?
That is the common fear. But the cost of not validating early is so much higher. With a compiled validator like OJV, the latency is negligible.
And the benefit is you reject bad data immediately.
Immediately. You protect all your downstream services. You save massive amounts of compute resources by only letting clean data into your system.
And the final recommendation?
Automate generation from the schema. That tooling we talked about, the type generators, the UI builders, integrated directly into your CI/CD pipeline.
This guarantees that your code, your documentation, your UI, and your tests are always in sync with the data contract.
You basically eliminate an entire class of cross-team integration errors before the code is even deployed.
So when you put it all together, JSON schema really is a fundamental shift. It takes data exchange out of this realm of, guesswork and implicit agreements.
And it moves it into a machine-readable, explicit contract. You guarantee integrity, you get modularity, and you accelerate your entire development lifecycle.
The source material we reviewed frames it as the essential blueprint for your data, and I think that's the right way to see it.
It is. And if you choose not to define that blueprint, you aren't just building a shaky system. You are implicitly outsourcing your core data governance to the weakest, most inconsistent part of your entire stack, your application code. That's where silent failures happen and trust is destroyed.
A powerful thought to end on. If you want to dive deeper, the JSON Schema official site is the authoritative source for everything we've discussed today. You'll find specifications, tooling, and guides there, including more on the high-performance validator, JSON. Thanks for joining us for this deep dive.